Good morning. This is K.V. Rangarao, Assistant Professor, CSC, Vignan University. Today we are going to discuss about the concepts in discrete mathematical structures. So the contents we are going to discuss in today's class are what is discrete mathematics, what are the objectives, what is the course syllabus, what are the outcomes, what is propositional logic and their applications, and what are logical equivalences. So first we will discuss what is discrete mathematics. So we can define a mathematics as it is a part of mathematics which studies discrete objects. We can also define a discrete mathematics as study of mathematical structures which are fundamentally discrete rather than continuous, according to Wikipedia. In this way we can define a discrete mathematics. So next we will discuss about syllabus. In first unit we are going to discuss about propositional logic. In propositional logic we will discuss about what is propositional logic, what are their applications, what is propositional equivalence, predicates and quantifiers, nested quantifiers, introduction to proofs, proof and methods. All these concepts will be covered in first unit. In second unit we will study about set theory. So in second theory we are going to learn what are various sets, what are the various operations on set, and functions, sequence and summations, cardinality of set, counting, pigeonhole principle. All these concepts will be covered in second unit. In third unit we are going to discuss about recurrence relations. So what are recurrence relations? How we are going to evaluate the recurrence relations? What is divide and conquer algorithm? What are the generating functions? What is principle of inclusion exclusion? Their applications. All these concepts will be covered in third unit. As a part of fourth unit we will discuss about relations. What is a relation? What are their properties? What are n-ary relations? How to represent relations? What are the closures of relations, equivalence relations, and partial ordering? All these concepts will be covered in fourth unit. In fifth unit, we will learn about graphs. What is a graph? What are various graph models? What are the special types? How graphs are represented using matrices? What are the connectivity problems? What is Euler path? What is Hamilton path? What about Euler and Hamilton circuits? Graph coloring, all these concepts will be covered as a part of fifth unit. So objective. So objective of the learning discrete mathematics is first one, to learn how to use logical connectives to make compound statements. That means using propositional logic, two or more statements will be combined to create a meaningful statement. That is one of the objectives. Next one is how to draw conclusion from various arguments. That means from given set of statements, students should be able to derive to one conclusion. That is also one of the objectives. Next one is to become familiar with predicates and quantifiers. So after learning these concepts, students should be aware of the differences between universal quantifiers and existential quantifiers, where to apply universal, where to apply existential. Students will be aware of that. Next, to explore various operations on sets and to become familiar with Venn diagrams. How we can represent a set using Venn diagram. Student will be familiar. Next, explore various Euler, Hamilton graphs, graph coloring and isomorphism of graphs. All these are objectives of discrete mathematics. Next, outcomes. So what outcomes we are expecting from students after learning DMS? First one is students should be able to apply propositional logic, predicates and Boolean function to express the mathematical properties. Next one, they will be able to analyze the basic mathematical objects such as sets and relations to verify the mathematical properties. Next one, they will be able to find solutions for recurrence relations. Next one is they can design and develop solutions for various combinational and graph based problems. These are objectives of discrete mathematical, these are outcomes of discrete mathematical structures. So applications in computer field where we are going to apply the concepts of discrete mathematics. So in compiler design, in data structures, databases, artificial intelligence, computer architecture, operating system, graphics, animation. In all these fields, we can apply the concepts of discrete mathematics. So first we will discuss about what is a proposition. So we can define a proposition as declarative sentence which is either true or false but not both. For example, see the statement, Washington DC is the capital of United States of America. It is a declarative statement. We know that Washington is the capital of America. So as it is a declarative sentence and it is having true value, we can say that it is a proposition. Next, see one more thing. Toronto is the capital of Canada. It is also a declarative statement. We know that Toronto is the capital of India. So it is a proposition and its value is true. See the next statement, 1 plus 1 equal to 2. As everybody knows that 1 plus 1 is equal to 2, the statement is true. Hence we can say that it is a proposition. Hence we can define a proposition as the statement which can be either true or false but not both. Next, see some more examples on propositions. See one statement, C++ is the best language. We can say that it is not a proposition because just it is opinion, not a declarative statement. Hence, we can say that C++ is the best language is not a proposition. See the next one, when is the pretest? It is also not a proposition because it is not a declarative sentence. It is a interrogative sentence. Hence, the second one is also not a proposition. See the next one, do your homework. That is also not a declarative statement. It is a imperative sentence. Hence, we can say that the third statement is also not a proposition. Here some statement is given. We have to identify whether it is proposition or not. If it is a proposition, it is true or false. Here what we are given, x plus 4 greater than 9. Here we do not know the value of x. So without knowing the x value, we cannot say whether it is true or false. Such statements are called as open statements or open sentences. So open sentences means the statements which contains one or more variables and which is not true until it is assigned with some variable. Here x plus 4 greater than 9. Here x value is unknown. That's why this is a open sentence. If we assign any value to x, then only it will become a proposition. So we can say that the given statement is an open sentence and it is not a proposition. See one more example. Can Ali come with you? We know that a proposition should be a declarative statement, but this is not a declarative statement. It is a interrogative, question type statement. That's why we can say that this is also not a proposition. See one more example is given. Take 2 aspirins. It is not a proposition because it is an imperative sentence and not a declarative sentence. We know that only declarative statements which have either true or false, they only will be a proposition. As it is not a declarative statement, we can say that given statement is not a proposition. Next, what is propositional variable? So every proposition is denoted by some variables like small letters P, Q, R, S, etc. Using small letters, we can represent a proposition, and every proposition will have some true value. If it is true, it is denoted by capital T or 1, and if it is false, it is denoted by F or 0. So every propositional variable is indicated by lowercase letters, and if it is true, denoted by capital T or 1. If it is false, it is denoted by F or 0. This is about propositional variables. Consider one example, 1 plus 2 equal to 3. This is a proposition. This proposition is represented by the variable P. We know that 1 plus 2 equal to 3 is true. Hence, the truth value of the proposition P is true. Or some books it is represented as 1. Either true, T or 1. See the next example, 2 plus 2 equal to 5. It is represented with the variable Q. We know that 2 plus 2 is not equal to 5. Hence, the truth value of the proposition is false or 0. Here some more examples are given. We have to find the truth value if it is a proposition. See the first one, what time is it? We know that it is an interrogative type. So it is not a proposition. See the next one, Guntur is in Tamil Nadu. We know that Guntur is in Andhra Pradesh. Hence, second one is a declarative statement, but its value is false. See the third one, 4 plus x equal to 5. We know that it is an open statement because variable x is there, it is not assigned with any value. So, third one is not a proposition. See the last one, Ramnath Kovind is the current president of India. It is a declarative statement. We know that Ramnath Kovind is the current president. Hence, it is a proposition and its value is true. Next, see some more examples. First one, 2 plus 3 equal to 5 is the given statement. So, we know that 2 plus 3 is equal to 5 is true. Hence, it is true. See the next one, x plus 2 equal 11. We know that it is a open statement because it is containing a variable and it is not assigned with any value. So, it is a open sentence. Hence, not a proposition. See the next one, answer this question. We know that it is not a declarative statement. It is an imperative sentence. Hence, last one is also not a proposition. Next, we will discuss about logical connectives. So, what is a logical connectives? Why they are used? So, logical connectives are used to create a compound proposition from two or more propositions. That means, connectives are used to combine two or more propositions to create a single proposition, which is called as compound proposition. Following are the logical connectives. First one is negation, logical and or exclusive or implication by implication. All these are called as logical connectives, which are useful in creating compound statements. So here we will discuss about negation. So what is a negation? If you consider one P is a proposition, its negation can be represented by this symbol. So now we are going to discuss about negation. So what is the negation of a proposition? So if we consider a proposition P, its negation can be represented by this symbol tilde P or this symbol. In both ways we can represent negation of the variable. So if we construct truth table, we will have two rows, P, negation P. As we contain only one variable, there will be only two rows. One is true and another is false. So if proposition is true, its negation will be false. If proposition is false, its negation will be true. So in this way, we can represent negation of the proposition. So we can write negation of the proposition as not P or it is not the case. It is not the case that P. So in both ways we can represent negation of the proposition, not P or it is not the case that P. In both ways we can represent the negation of the proposition. See one example on the preposition. Here, today is Friday statement. So for this we have to take the negation. So negation P can be represented as today is not Friday. That is one method. Today is not Friday. That is one method. Second method is we can write as it is not the case. It is not the case that today is Friday. Both the ways we can write today is not Friday or it is not the case that today is Friday. In both ways we can represent negation of the given preposition. See one more example. Given statement is 6 is negative. We have to find the negation. So we can write in two ways. One is 6 is non-negative. That is one way. Otherwise it is not the case that 6 is negative. So when we are using the notation it is not the case, after that the given statement should be written as it is. That's why negation of the statement 6 is negative can be expressed as it is not the case that 6 is negative or 6 is non-negative. In both ways we can represent the negation of the given statement. See one more example. May has MP3 player. We can write in two ways. May doesn't have MP3 player. That is one way. Second way is it is not the case that May has an MP3 player. In both ways we can express as a negation of the given sentence. Next statement is 2 plus 1 equal to 3. We can write in two ways. One way is 2 plus 1 not equal to 3. 2 plus 1 not equal to 3. That is one way. And another way is it is not the case that 2 plus 1 equal 3. In both ways we can write the negation of the given statement. Next one more example. Here Jennifer and Teja are friends. Here the given statement is Jennifer and Teja are friends. So that is the given statement. For this we can write in two ways. One is Jennifer and Teja are not friends. Jennifer and Teja are not friends. That is one way. And another way is it is not the case. It is not the case that Jennifer and Teja are friends. Jennifer and Teja are not friends, or it is not the case that Jennifer and Teja are friends. In both ways we can represent the negation of the given statement. Similarly, there is one more problem. There are 13 items in a baker's dozen. In two ways we can represent. There are no 13 items in a baker's dozen. That is one way. Second method is it is not the case that there are 13 items in a baker's dozen. Next one, Abhay send more than 100 messages every day. We can express in two ways. Abhay doesn't send more than 100 text messages every day. That is one method. Second method is it is not the case that Abhay send more than 100 text messages every day. In the both ways we can represent negation of the given statement. Next we will discuss about conjunction. So conjunction between two preposition variables P and Q is denoted as P and Q. We read symbolically it is represented like this, P meet Q. So P meet Q will be true when both P and Q are true. If at least one is false, conjunction will be false. Observe the table. If you observe the table, when P is true and Q is true, in that case only conjunction is getting true. In all remaining cases, conjunction is false. So we can say that conjunction is true when both P and Q are true. If at least one is false, then the conjunction getting false. This is about conjunction. Here one example is there. One statement is given that today is Friday. Q is defined as it is raining today. So we have to find conjunction for this. So conjunction between P and Q is written as P and Q. That means today is Friday and it is raining today. In that way we can represent conjunction for the given statement. Next we will discuss about disjunction. So conjunction will be true only when both P and Q are true. Similar to that, disjunction is denoted by P is and Q. According to the table, we can understand that disjunction will be true if at least one of P and Q is true. And disjunction will be false only when both P and Q are false. In that case only disjunction false. In all remaining cases, disjunction is giving true. That is about conjunction between two prepositions P and Q. So it is read as P or Q. So conjunction will be false in only one case. When both P and Q are false, in that case only disjunction will be false. In all remaining cases, it will be true. This is about disjunction between two prepositions. See, here some examples are given. It is raining, or this is the second lecture. 2 plus 2 equal to 5, or 1 less than 2. You may like cake or ice cream. This statement will be true if at least one of these statements is true. For example, see the first one. This is a compound proposition because this is one statement, this is one statement, both are connected with or. So it will be true if at least one of the propositions is true. Either it is training should be true or this should be true. If at least one is true, then only it will be true. If at least one is false, it will be, if both are true, then only it will be false. So these are examples for disjunction. See one more example. Here the proposition P is representing today is Friday. The variable Q is representing it is raining today. We have to express its disjunction. So disjunction can be expressed as P or Q. So it can be read as today is Friday or it is raining today. So that is the solution for the given one. Next we will discuss about exclusive OR. So if you observe the table, we can understand how an exclusive OR works. If you observe, when both are having same value, whether it may be true or false. When both variables are having same truth value, in that case exclusive OR getting failed. Here both are false. In that case exclusive OR giving false. Here both are true. In that case also it getting failed. That means exclusive OR will be true if exactly one of P and Q is true. If both are having same value, that is either true or false, in that case exclusive OR will be false. So see some examples. If you take any circuit, it will be in either on mode or off mode, but not both. Similarly, if you take product AB is less than 0. If it is true, then either A must be negative or B must be negative, but not both. You may have cake or ice cream, but not both. All these are examples for exclusive OR. So we can say that exclusive OR is true if exactly one of P and Q is true.